Our application is running for many years. You have to make sure that you have no foreign material, presence of nuts, almond. And welcome to the Euresys booth. So my name is Jean-Marie Jolet. I am Senior Sales and Support Engineer. As you can see on the booth, we have several demos which highlights our products, our latest products for different segments, for different markets. So I guess you are here for the food and beverage market. Okay, this is correct. For this market, we have our demo, which is here. It is based on deep learning. This is an object detector. The goal of this demo here is to detect the presence of foreign material into chickpeas. So we detect presence of nuts, almond, cashew nuts in chickpea. And this is all based on deep learning, based on object detection. I have a question for you. Why do you think that deep learning is well adapted for food industry? Do you have any reason? Yeah? What's the reason?
Oh, because it high variation, very high variation.
Exactly. This is exactly the reason. So Mother Nature can be very inventive when it comes to shape, size, color of fruit and vegetables. And classical algorithms, they have some hard time to deal with this variability, which is not a problem for deep learning. So unlike rule-based algorithm where you have to provide a detailed description of what you are looking for, what the object or what's the defect you are looking for, in case of the deep learning approach, you just have to train a neural network with a set of images that can be annotated to say, okay, this one represents a nut, this one represents an almond, this one represents some chickpea, and this kind of thing. So it's pretty easy just to train the neural network with those images. And after that, the system is able to automatically locate the object of interest. So it means that in terms of programming, since you don't have to write code to describe in detail what is the defect or what it looks like, you gain some time. So it reduces integration cost and it does also faster time to market. There is also another advantage in the deep learning approach. This is for the evolution and the maintenance of this kind of application. So let's suppose that we are all developers of software and we want to detect defect into spinach leaves. Okay, we have developed our application. It is able to detect defective leaves and report them. So our application is running for many years. Customers are very happy about that. It's really robust. But unfortunately, one disease appears that affects the appearance of the spinach leaf. Of course, our customer come to us and say, okay, we need to upgrade your software to be able to detect a new defect. Well, in case of deep learning, that's pretty easy. You just have to add images of this new defect into your data set. You train the neural network with the updated data set, and there you go. The application is now able to detect the new defect. It's taken into account without the modification of a single line of code. And this is maybe the most important thing here, without the modification of a single line of code. If you have to apply the same evolution to a conventional based algorithm software, then in this case you have to rewrite a significant part of your software, which is not the case here. So in this demo here, we are using our EasyLocate library, which is used for localization and identification of products. And it is used in combination with an SVS Vista camera, so in the EXO series cameras. The fact that these two can be very interesting is that before in the food industry, before sealing or before packaging the stuff, you have to make sure that you have no foreign material. So it means that the tool needs to be able to find exactly the location of the foreign material because we need to remove it. But we also need to understand what is the type of defect, what is the type of foreign material, because we need to understand at which stage of the process this foreign material has been introduced. So using our tool, that's perfectly what it's doing. Okay, so talking about this library, so EasyLocate, the annotation is pretty easy. You just have to take some images, you just place a box around the object that you have detected, you label this box, you can define different type of material. So it's pretty easy. You just drag and drop some boxes. Very easy.